Hi, I'm Alex. Tonight we're traveling 10 billion light years away to meet something so large that scientists doubted it could exist. It's not a galaxy. It's not a cluster of stars. It's a single black hole so massive that its edge would stretch far beyond the orbit of Pluto if placed in our solar system. With the mass of 66 billion suns and the brightness of hundreds of trillions of stars, this object forces us to ask a simple question: how did the universe create something this extreme? If journeys like this spark your curiosity, a gentle subscribe helps this journey keep growing and quietly offering more. Now let's begin. The defining night of 2004, a team of astronomers ran the calculations for the seventh time. The computer must be malfunctioning. It had to be. They checked the code. They verified the input data. They cross-referenced with 3 independent measurement systems. Every single time, the same impossible number stared back at them from the screen, glowing like an accusation in the darkness of the observation room. One astronomer, a veteran of 30 years who had discovered 17 supernovae and cataloged thousands of distant galaxies, sat back in his chair and whispered words he had never spoken in his entire career. I don't know what we're looking at. They were not wrong. The universe was wrong. Or more precisely, everything we thought was right about how nature operates, about what physical laws permit, about the limits of cosmic possibility, turned out to be catastrophically, beautifully, terrifyingly wrong. This is TON 618, a black hole weighing 66 billion times the mass of our sun. This number is not merely large. It is not simply unprecedented. It is fundamentally impossible, according to everything we understood about how black holes form, how they grow, how much time they have had to exist since the Big Bang. The number itself is an assault on reason, a violation of cosmic law, a thing that should not be. The event horizon, that boundary beyond which nothing can escape. Not even light traveling at its maximum speed of 300 million meters per second extends to a radius 40 times farther than Pluto's orbit around our sun. Read that again. The point of no return around this black hole is larger than our entire solar system, larger than the region containing every planet we have ever known, every comet. Humanity has observed every spacecraft we have ever launched into the cosmic void. If you place this black hole where our sun sits, the event horizon would swallow Earth instantly, devour Mars, without pause, consume Jupiter and Saturn like dust motes, and extend far beyond Neptune into the Kuiper Belt, that distant realm of frozen worlds and primordial ice. It shines this thing that should not shine with the luminosity of 140 trillion suns. Think about that. Our sun, that vast nuclear furnace 93 million miles away, that gives life to everything on Earth, that bathes our world in light and warmth, that seems infinite in its power, multiply its brightness by 140 trillion. This is the light pouring from TON 618, from a region no larger than our solar system, generated not by fusion, but by destruction, by matter being torn apart and annihilated in the most violent gravitational field in the known universe. The light has been traveling for 10 billion years to reach us. When these photons began their journey across the cosmos, Earth did not exist. Our sun had not yet ignited in its stellar nursery. The atoms that would one day compose your body were scattered across interstellar space in clouds of gas and dust. The universe itself was barely 1/4 of its current age, younger, more violent, more chaotic than the relatively calm cosmos we inhabit today. We are not seeing TON 618 as it exists now. We are seeing a corpse, a ghost, an echo from when the universe was still forming its first massive structures. Now imagine this. If we could somehow swap TON 618 into the position where our sun currently sits, replacing our life-giving star with this cosmic monster, what would happen Earth gone? Not destroyed in the sense of being broken apart, but simply vanishing beyond the event horizon, ceasing to exist in any meaningful way, as information about its matter became forever locked behind that boundary. Mars erased, the asteroid belt consumed, Jupiter, Saturn, Uranus, Neptune swallowed whole. Even the Kuiper belt, that distant frontier of icy bodies 4 billion miles from the sun, would find itself inside the event horizon. Everything you have ever known about our solar system, every planet you learned about in school, every space mission you have followed, every astronomical photograph that moved you, all of it would be nothing more than dust in the mouth of a monster. The escape velocity at the event horizon equals infinity, not very, very fast, not close to the speed of light, infinite. Mathematics does not accept exceptions to this rule. Once you cross that boundary, return is not difficult or unlikely or improbable. Return is mathematically impossible, forbidden by the geometry of space-time itself. In 1915, in a trench on the eastern front of World War I, surrounded by the sounds of artillery fire and the cries of dying men, a German physicist named Karl Schwarzschild lay dying from a painful autoimmune disease contracted in the trenches. In between bouts of agony, using only paper and pencil, he solved Einstein's newly published equations of general relativity and discovered the mathematical possibility of black holes. He sent his calculations to Einstein, who read them with growing unease and wrote back, "This cannot happen in nature." Einstein believed the mathematics was correct, but that the universe would never actually create such objects. He was wrong. The universe does not care what Einstein believed. Nature is under no obligation to respect our intuitions about what should or should not exist. The physicist John Wheeler, who coined the term black hole in 1967, once said, "Nature does not care whether humans understand it or not. It simply does what it wants, and sometimes what it wants is to create hell. 66 billion times the mass of our sun. If the sun were a golf ball, TON 618 would be, stop. Stop trying to visualize it. Your brain is not designed for this task. Comparing these objects is like an ant trying to comprehend a Swiss bank. The scale difference exceeds biological limitations. The human mind evolved to understand distances, measured in steps, weights, measured in handfuls, numbers counted on fingers. We did not evolve to grasp billion. We certainly did not evolve to grasp 66 billion solar masses compressed into a region whose boundary would engulf our solar system. But here is what they did not tell the public immediately, what took years of additional observation and analysis to confirm what still makes some astronomers uncomfortable when they discuss it. How do you see something that does not emit light? Something located 10 billion light years away, something separated from us by an expanse of space so vast that light itself requires 10 billion years to cross it. The answer will keep you awake at night, because TON 618 is not silent in the way we imagine black holes to be. It is not sitting quietly in the darkness of space. It is eating, consuming matter at a rate of 20 to 30 times the mass of our sun every single year. It is feeding on gas, on stars, on everything unfortunate enough to wander too close, and we can hear it. Not with our ears. Obviously, sound cannot travel through the vacuum of space, but we can hear it. With our instruments, detect the screaming radiation from matter being shredded apart just before it crosses the event horizon, measure the X-rays and gamma rays from plasma heated to billions of degrees by friction and magnetic fields. We hear the cosmic scream of matter meeting its doom. And that scream has been traveling toward us for 10 billion years, finally reaching Earth in 2004, when those astronomers ran their calculations for the 7th time and realized they were looking at something that should not exist. This is not a story about a black hole. This is a story about the moment we realized the universe is far stranger, far more violent, and far more magnificent than we ever imagined. We begin our journey from Earth, that fragile blue planet suspended in the darkness of space, a world so small and delicate that from even a modest distance, it vanishes into insignificance, becoming just another pale dot among billions. This is home, the only home our species has ever known, a world of oceans and continents of life, an abundance of 7 billion human beings going about their daily existence, completely unaware of the cosmic monsters lurking in the depths of space and time. Look up at the night sky from any dark location far from city lights, and you will see a faint, milky band of light stretching across the heavens. This is the Milky Way, our home galaxy, a vast spiral structure containing 400 billion stars, each one a sun in its own right, many of them surrounded by their own families of planets. Somewhere within this river of stars, about 26,000 light years from the galactic center, orbiting peacefully in one of the spiral arms, sits our sun, with its retinue of 8 planets, countless asteroids, and all the worlds we have ever known. At the heart of our galaxy, in the exact center of that spiral structure, lurks Sagittarius A star, the supermassive black hole that anchors the rotation of our entire galactic home. It weighs 4 million times the mass of our sun, a monster by any reasonable standard, massive enough that its gravitational influence extends across thousands of light years, shepherding the orbits of billions of stars, including our own sun. For decades, astronomers thought this was what supermassive meant. They believed 4 million solar masses represented the upper end of what black holes could achieve. But compared to TON 618, Sagittarius A star is an ant. TON 618 is a mammoth frozen in cosmic ice, a colossus so massive that our galactic black hole would be nothing more than a rounding error in its mass calculation. The ratio between them is 16,000 to 1. Imagine trying to compare a grain of sand to a boulder, and you begin to approach the scale difference we are discussing. In 2020, Reinhard Genzel and Andrea Ghez shared the Nobel Prize in Physics for their patient, meticulous observation of a single star, designated S2, tracking its orbit around Sagittarius A star for 16 years. They watched it dance with death swooping to within 17 light hours of the event horizon, traveling at 7,650 kilometers per second at its closest approach, fast enough to circle the Earth's equator in 6 seconds so fast that time itself bends and warps around it. Time bends. Read that again. Not seems to slow down or appears different. Time actually, physically, measurably bends around this star as it screams past the black hole at nearly 3% of the speed of light. According to Einstein's theory of relativity, a clock on S2 at its closest approach would tick measurably slower than a clock on Earth. This is not theory. This is not speculation. This is observable reality happening right now every 16 years. When S2 makes its periapsis passage, relativity is not an abstract mathematical curiosity. It is the way the universe actually works, the fabric of reality itself, flexing and warping under the influence of gravity. Now, we accelerate beyond the speed of light in this thought experiment, breaking the cosmic speed limit to hunt the past, racing outward from our galactic home at velocities that would make physics professors weep. As we push faster, the Milky Way begins to shrink behind us, its spiral structure becoming clear, for the first time revealing graceful curved arms, winding outward from a bright central bulge, dark dust lanes where new stars are being born, bright regions of active star formation scattered throughout the disk like jewels on velvet. The design is beautiful and terrible. A structure containing hundreds of billions of stars, arranged in patterns carved by gravity over billions of years, a blueprint of cosmic architecture that is simultaneously gorgeous and ruthless. Neighboring galaxies begin to appear as we push outward through intergalactic space. First come the large and small Magellanic Clouds, our satellite galaxies, smaller, irregular structures orbiting the Milky Way, like moons around a planet containing billions of stars, each visible to the naked eye from the southern hemisphere as fuzzy patches of light. Then Andromeda emerges from the darkness, our nearest large spiral neighbor, a galaxy perhaps twice the size of our own, containing possibly 1 trillion stars, each one a sun, many of them accompanied by worlds we will never see, never visit, never know. Then come dozens more hundreds, thousands of galaxies, each containing hundreds of billions of stars, each star potentially hosting planets, each planet potentially harboring life. Andromeda is approaching us at 110 kilometers per second. In approximately 4 billion years, our two galaxies will collide, sound far away, on the cosmic timescale that is tomorrow morning, the very near future, practically around the corner. When the collision comes, and it will come as inevitably as sunrise, the two spirals will interpenetrate stars, passing through the gaps between other stars, like interpenetrating clouds, gravity pulling and twisting both galaxies into new shapes, triggering waves of star formation as gas clouds collide and compress. At the center of this chaos, Sagittarius A star and Andromeda's central black hole, which itself weighs perhaps 100 million solar masses, will spiral toward each other in a deadly embrace, eventually merging to create a new monster weighing perhaps 104 million solar masses, releasing more energy in gravitational waves during the final seconds of merger than all the stars in the observable universe emit in light over the same time period. To grasp the true scale of our local cosmic neighborhood, if the Milky Way were the size of a quarter, that small coin you might have in your pocket right now, Andromeda would be another quarter about 60 centimeters away. Sounds close, doesn't it? Walking distance. Arm's reach. Nothing. Now imagine 2 million other galaxies within a radius of 1 kilometer, all of them moving, all of them engaged in an ancient gravitational dance carved by dark matter and shaped by 13.8 billion years of cosmic evolution. And we are not standing still in this cosmic ocean. We are falling towards something pulled by gravity. We cannot fully see, dragged toward the monster, bigger than all of them. Time travel is not science fiction. When you move faster than light in thought, when we exceed the speed of light in our imaginary journey, when we break causality itself, time begins to flow backward. We are not merely looking into the past, the way we do when we observe distant stars whose light left them years or centuries ago. We are traveling into the past, physically moving backward through cosmic history, witnessing the universe as it was billions of years ago. Every light year of distance equals 1 year of temporal regression. Cover 1 million light years, and you have stepped 1 million years into history. Cover 1 billion light years, and you have reached 1 billion years into the past. Every increment of space becomes an increment of time, distance, and duration, merging into the unified space-time that Einstein showed us was the true nature of reality. Every time you look at the night sky, you are flipping through an old photo album, a record of cosmic history written in light. The light from the most distant stars, visible to the naked eye stars, like Deneb or Ida Carinae, might have begun its journey before your ancestors crawled onto dry land, before the first fish developed lungs and limbs, before multicellular life itself emerged from the primordial oceans. Some of the stars you see on a clear night are already dead, their light still traveling through space, long after the stars themselves exhausted their nuclear fuel and collapsed into white dwarfs or exploded as supernovae. You are looking at ghosts at light that is all that remains of objects that ceased to exist before human civilization began, before our species evolved, before our planet cooled enough to have liquid water on its surface. Andromeda will collide with us in 4 billion years. Worried? Don't be. You will not be here. Your children will not be here. Your children's children multiplied through 10,000 generations will not be here. Humanity itself, assuming we survive climate change and nuclear weapons and asteroid impacts and artificial intelligence and the 1,000 other ways a technological species can end, will likely not be here, will probably have evolved into something different or gone extinct or transcended biology entirely, or spread to other stars or done something we cannot currently imagine. But the black holes will still be here. They always are. They outlast everything. They outlast stars, galaxies, civilizations, perhaps even the universe itself. And they will be bigger after the merger, more massive, more powerful, more capable of warping space-time around them. This is not a story about a black hole. This is a story about how we dare to look at things we should not look at, how we point our telescopes and our instruments and our brilliant mathematical minds at objects that should terrify us, how we measure and calculate and theorize about cosmic monsters that could erase everything we love without noticing we ever existed, without registering our presence, without caring One bit about the 7 billion hairless apes on a small wet rock who happened to develop enough intelligence to see them across cosmic distances. And we keep looking. We always keep looking. That is what makes us human. We have just left home. Now we step into the void, into regions where there is nothing except darkness, cold, and things so ancient they remember the Big Bang itself. And one of them is waiting for us. We enter the space between galaxies, and the darkness becomes absolute in a way that earthbound humans can never truly experience. This is not the darkness of a moonless night, or a deep cave, or even the depths of the ocean where sunlight fades to nothing. This is the darkness of cosmic voids, regions so empty that you could travel for millions of light years in any direction without encountering a single star, without seeing anything except the faint, distant glow of galaxies scattered across the incomprehensible distances, like islands in an infinite ocean of nothing. The emptiness here is profound, in ways that challenge human intuition and defeat all our attempts at analogy. You could fly through this region for millions of years at the speed of light, moving at 300 million meters per second, and never touch a star, never pass near a planet, never detect any object larger than scattered atoms of hydrogen drifting through the void like dust motes in a cathedral made of darkness. The scale is so vast that comparisons fail. If you removed all the stars from a galaxy and spread them evenly throughout intergalactic space, each star would be separated from its nearest neighbor by distances measured in light years, distances so large that light itself, traveling at its cosmic speed limit, would require years or decades or centuries to cross the gap between one star and the next. The temperature here hovers just barely above absolute zero, that theoretical lower limit where all molecular motion ceases, where atoms themselves would freeze into stillness, if such a thing were physically possible. Negative 273 degrees Celsius, or more precisely about 2.7 Kelvin, warmed only by the cosmic microwave background radiation, the faint afterglow of creation itself radiation that has been cooling and redshifting for 13.8 billion years. As the universe expands and ages, and the space between galaxies stretches ever wider. But the void is not truly void. The matter density here equals approximately 1 hydrogen atom per cubic meter. Sounds like nothing. Sounds like empty space deserves its name. Multiply that by infinity, and you have enough raw material to build galaxies, enough hydrogen to forge billions of stars, enough matter to create everything we see in the observable universe. Space is not empty. It is merely very, very sparse. The matter spread so thin that it might as well be nothing but accumulated over cosmic volumes, integrated across billions of light years. It becomes everything, the raw material from which stars and planets and people are made. That 2.7 Kelvin temperature, that faint warmth pervading all of space, is ghost light from 380,000 years after the Big Bang, the moment when the universe cooled enough for atoms to form, when electrons and nuclei combined for the first time, and photons could finally travel freely through space without being immediately absorbed and re-emitted by free electrons. That moment is called recombination, and it marks the birth of transparent space, The instant when the universe went from opaque to clear, from a fog of plasma to the darkness we see today. That radiation has been stretching and cooling ever since red shifted by cosmic expansion from visible light down through infrared, down through microwaves, down to the faint radio whisper we detect today. You are bathing in the remnants of creation, surrounded by light older than stars, older than galaxies, older than anything except the universe itself. You are swimming in the afterglow of the Big Bang, scattered through this near emptiness, invisible but omnipresent, providing the gravitational scaffolding upon which all visible structure is built, lurks dark matter, the invisible mass that comprises 85% of all matter in the universe, but which we have never directly detected, never directly observed, never touched or measured, except through its gravitational effects on the things we can see. We see galaxies rotating too fast to be held together by their visible matter alone. We see galaxy clusters moving in ways that require far more mass than we can account for with stars and gas and planets. We detect gravitational lensing, the bending of light by gravity on scales that demand enormous unseen masses warping space-time. It is like seeing footprints in snow, but never seeing the creature that made them, like feeling a presence in the darkness, but never glimpsing what watches from the shadows, like knowing something is there because of how it affects everything around it, while remaining itself completely invisible. Dark matter surrounds us, pervades us, flows through us, at this very moment outweighs ordinary matter by a factor of more than 5 to 1, and we do not know what it is. Particle field, modified gravity, something stranger still, we do not know. This is one of the great unsolved problems in physics, a mystery that has persisted for nearly a century despite our best efforts. As points of light begin to emerge from the darkness, thousands upon thousands of galaxies becoming visible as we travel deeper into space. And further back in time, we observe that they are not randomly distributed across the sky like points thrown onto a canvas. Galaxies cluster along vast cosmic webs, filaments and sheets and walls of matter separated by enormous voids. This is the large-scale structure of the universe superstructures, stretching across billions of light years, carved by gravity over cosmic time. As matter flowed along invisible rivers of dark matter, clustering into dense knots where galaxies form, and leaving vast empty spaces between the filaments. From a great enough distance, if you could somehow step outside the universe and look back at it, the cosmic web looks eerily like a human brain, neurons and synapses on a cosmic scale. Galaxies clustered at intersections like cell bodies, while vast voids separate the filaments like the spaces between neurons. Some scientists joke, though nobody laughs when they say it. Perhaps we live inside a gigantic brain. The resemblance is unsettling, the patterns too similar to be entirely comfortable raising questions about structure and complexity, and whether the universe itself might be more organized, more connected, more purposeful than we dare to imagine. Somewhere out there in the darkness, beyond our ability to observe directly, hidden behind the zone of avoidance, where the plane of our own galaxy blocks our view of the deeper universe, lurks something called the Great Attractor, an anomaly with the mass of 100,000 trillion suns pulling our galaxy and thousands of neighboring galaxies toward itself. at 600 kilometers per second. We do not know what it is. We cannot see it directly because it lies behind too much intervening matter. We only know we are falling toward it, have been falling toward it for billions of years. Pulled by gravity, we cannot fully account for dragged across cosmic distances by something massive beyond our current ability to observe. We are not in control of our trajectory through space. We never were. Have you ever woken in the middle of the night, alone in a dark room, and felt the space around you seem too large, too empty, pressing in on you, with its absence, the darkness, feeling more solid than the walls, more present than the furniture? Take that feeling and multiply it by 1 billion. That is where we stand now, in the cosmic void between galaxy clusters, in the emptiness between structures, in the darkness between lights, in a place where human scale and human intuition and human comfort have no meaning whatsoever. If you got lost here, Edordore is not coming to rescue you. Roadside assistance does not operate in intergalactic space. Cell phone signal, forget it. Radio waves, they would take millions of years to reach anyone who might be listening. The nearest galaxy, several million light years away in any direction you choose to travel. Basically, this is Nevada, but worse, far worse, incomprehensibly worse, in its scale and desolation and absolute indifference to human existence and human needs. But wait, ahead of us, a point of light, brighter than everything else, not a star, not a galaxy. It shines brighter than 100 billion stars combined, and it should not exist here at this moment in time, but it does, and it is looking at us. The quasar emerges from the cosmic darkness like a beacon, like a lighthouse shining across distances that dwarf human comprehension. But this is not a gentle guiding light meant to lead ships safely to harbor. This is something else entirely, something that burns with a violence and intensity that makes our sun look like a dying ember, something that should not exist, and yet blazes across 10 billion light years with a fury that seems almost intentional, almost personal. In the early 1960s, when astronomers first began cataloging these strange objects, they thought they were looking at peculiar stars within our own Milky Way galaxy. The objects appeared as points of light, showing no structure, even in powerful telescopes, looking for all the world like stars, perhaps unusual stars with strange spectral properties, but stars nonetheless. They called them quasi-stellar radio sources because they emitted strong radio waves and looked stellar, star-like ordinary, except for their odd radio brightness. No one suspected the truth. No one imagined what they were actually seeing. Then came the spectral analysis, the careful measurement of light broken into its component wavelengths, revealing the characteristic fingerprints of different elements, and astronomers found something impossible. The spectral lines were shifted dramatically toward longer, redder wavelengths, stretched out like someone had grabbed both ends of the spectrum and pulled, indicating these objects were receding from us at tremendous velocities, often 10% or more of the speed of light velocities, so extreme that nothing in our galaxy moves that fast relative to Earth. According to Hubble's law, that fundamental relationship between velocity and distance in an expanding universe discovered in the 1920s If something is moving away from us at 10% of light speed, it must be billions of light years away, so distant that its light has been traveling toward us since before our planet existed, since before our sun ignited. If these objects were visible at such distances, bright enough to detect across billions of light years, they had to be incredibly luminous, more luminous than entire galaxies containing hundreds of billions of stars. Yet they appeared as points suggesting all this energy came from regions no larger than our solar system, smaller than the distance from the Sun to Pluto. The energy density was higher than anything previously encountered in nature, brighter than an entire galaxy, but concentrated into a region smaller than a single solar system. The numbers made no sense. The physics seemed impossible, and yet there they were, dozens of them, hundreds of them scattered across the sky like cosmic fires burning in the ancient universe. The solution, which became clear through the 1960s and 1970s as theory caught up with observation, was supermassive black holes consuming enormous quantities of matter. As material spirals inward through accretion disks, heating through friction and magnetic interactions, it radiates vast amounts of energy before crossing the event horizon. This is not fusion like in stars. This is something far more efficient, far more violent matter being destroyed at the edge of oblivion, screaming its final transmission across cosmic distances before vanishing forever. TON 618 was first cataloged in 1957 at the Tonantzintla Observatory in Mexico during a photographic survey of blue stars entry, number 618 in a catalog of thousands. For decades, it remained largely ignored, one more blue point among thousands. In a stellar survey filed away in archives, forgotten, just another data point that no one thought to examine more closely because the technology and theoretical framework needed to recognize its true nature did not yet exist. When astronomers finally turned their attention to this object decades later, when technology had advanced enough to measure its properties in detail, one wrote in his observing notes, "This is the strangest star I have ever seen." He did not know it was not a star. He did not know he was looking at the grave of 1 billion stars, at a cosmic cemetery where matter goes to die, at something so massive and so violent that it defies every intuition about how the universe should work. The redshift measurement came back at Z equals 2.2219, meaning the light has been stretched by a factor of 3.2 as it traveled through expanding space for 10 billion years. Ultraviolet light emitted near the black hole has been stretched into red light by the time it reaches us. Blue light has become infrared. It is like hearing someone scream from the bottom of a well, the sound stretched and distorted by distance and by the Doppler effect. But you can still hear the terror, still detect the violence of what is happening, even though it happened so long ago that the universe was a different place, younger and more chaotic and far more violent than the relatively calm cosmos we inhabit today. The power output equals 4 times 10 to the 40th watts. This number means nothing to human intuition, so let me translate. Every single second, TON 618 releases energy equivalent to detonating 1 billion atomic bombs. Not once, continuously, every second, every minute, every hour, every day, every year, for millions of years. The scale is so absurd that it defeats comprehension that it overwhelms the human capacity to understand magnitude. If you placed TON 618 at the distance of Alpha Centauri, our nearest stellar neighbor, at 437 light-years away, it would appear 10,000 times brighter than our Sun appears from Earth. The radiation would boil our oceans within hours. The atmosphere would be stripped away, blown into space by the intense stellar wind and radiation pressure. The surface of Earth would become molten rock before you finished reading this sentence, before you had time to understand what was happening, before you could do anything except experience a brief moment of terrible realization, followed by instant vaporization. In 1963, Dutch-American astronomer Martin Schmidt was examining the spectrum of an object designated 3C273, one of the brightest radio sources in the sky. He stared at the spectral lines for hours, trying to make sense of what he was seeing, until suddenly the pattern clicked into place, and he realized he was looking at ordinary hydrogen lines, shifted by an enormous redshift. He had just identified the first quasar, the first confirmed example of these impossibly distant, impossibly luminous objects. That night, he could not sleep. He later wrote, "I had just seen something that should not exist, and there are thousands more like it out there." The 1970s saw fierce debate in astronomy departments around the world. Half the scientists said quasars were powered by supermassive black holes. The other half said, impossible nothing can be. That massive nothing can release that much energy. You are making a fundamental error somewhere in your calculations. Arguments became heated. Careers were staked on competing theories. And then slowly, as more evidence accumulated, as theoretical models improved, as observations became more precise, the universe proved one side wrong. Black holes were not only possible, they were real, they were common, and some of them were monsters beyond imagination. You know the feeling of looking into a furnace or a fireplace and having to turn away because the light is too bright, the heat too intense. Imagine looking into a furnace larger than our entire solar system, a furnace that burns not with chemical fire, but with gravitational violence, that consumes not wood or gas, but stars and planets, and everything that ventures too close. And it looks back at you. Quasar, quasi-stellar radio source, the scientific name for what the hell is this thing? Like calling Godzilla an unidentified large reptilian organism, technically correct, but missing the essential point, which is that this is not just an object, but a phenomenon, not just a source of light, but a destroyer of worlds, not just a black hole, but something that approaches the theoretical limits of what gravity can create in our universe. And here is what nobody tells you, what gets buried in technical papers and glossed over in popular accounts. TON 618 is not the most powerful quasar. It is not the most distant, but it is unique. It is special in a way that makes some astronomers uncomfortable, that raises questions we do not yet know how to answer, because it exists when it should not exist, because it is too massive for its age, too large for the time it has had to grow, too bright for the theories we have developed to explain how black holes form and evolve. And as we approach closer, as we descend toward this cosmic monster, we will see why, and why some scientists wish they had never found it. We approach TON 618, and the quasar resolves from a point of light into a disk, then into a vast churning maelstrom, a cosmic whirlpool of doomed matter spiraling toward destruction. This is the accretion disk, the structure that makes quasars visible across cosmic distances, the engine that converts mass into energy with terrifying efficiency. The disk extends for thousands of astronomical units, thousands of times the distance from Earth to the Sun, a structure so vast that light takes days to cross from one edge to the other. And yet this is tiny compared to galaxies, microscopic compared to the distances we have traveled, concentrated violence on a scale that seems designed to maximize destruction while minimizing the space required. The accretion disk does not simply rotate, it writhes. Matter does not fall straight into the black hole, but spirals inward, twisting and bending under the influence of gravity and angular momentum, shearing and tearing as different layers move at different speeds, screaming its existence through the radiation it produces as friction converts orbital kinetic energy into heat, like water spiraling down a drain, but this drain leads to nowhere, to a singularity where space and time themselves break down, where the laws of physics, as we understand them, cease to apply. The outer regions of the disk, extending from perhaps 1,000 to 10,000 astronomical units, have temperatures around 3,000 Kelvin, hot enough to melt steel hot, as the surface of red dwarf stars, glowing with a dull red heat that would vaporize any material we know how to manufacture. Matter here orbits at 300 kilometers per second, fast enough to travel from New York to Tokyo in 30 seconds, velocities that seem impossible by terrestrial standards, but which are sedate, almost leisurely, compared to the inner regions. And this is the cool part of the disk, the safe zone, the place where matter has not yet begun to experience the full force of the black hole's gravity, moving inward to about 100 astronomical units. Conditions intensify dramatically. Temperatures reach 100,000 Kelvin hotter than the surface of the hottest stars, so hot that atoms cannot hold together in their normal form. The gas has become plasma, fully ionized, electrons stripped away from nuclei by the intense heat and radiation. Matter here moves at 3,000 kilometers per second, 1% of the speed of light, so fast that relativistic effects begin to become noticeable, so fast that the kinetic energy alone is sufficient to annihilate any complex molecules. The magnetic field strength reaches 1 million times that of Earth's magnetic field, powerful enough to trap and channel plasma, to store enormous amounts of energy that periodically releases in flares and eruptions. If you somehow existed here, you would not die in any conventional sense. You would simply cease to exist, as matter, your atoms, ripped apart, ionized, incorporated into the plasma flow. The innermost region within 10 astronomical units of the event horizon experiences temperatures of 10 billion degrees Kelvin, 1,000 times hotter than the core of our sun, hotter than anything in nature, except perhaps the first moments after the Big Bang or the interiors of colliding neutron stars. Matter moves at 30 to 50% of the speed of light. Time dilation becomes significant. Clocks here would tick noticeably slower than clocks at rest, far from the black hole. Space itself is warped, curved so severely that straight lines become circles, that the shortest distance between 2 points is no longer what Euclidean geometry would predict. You cannot see this region in any normal sense because light itself is bent so strongly by the gravitational field that it creates optical illusions, mirages multiple images of the same object appearing in different locations. The innermost stable, circular orbit, abbreviated ISCO, marks the final boundary, the last place where matter can maintain a stable orbit without falling inexorably toward the event horizon. The exact radius depends on the black hole's spin. For a non-rotating black hole, it sits at 3 times the horizon radius. For a maximally rotating one, much closer, just over 1 horizon radius. For TON 618, with its 66 billion solar masses, ISCO likely lies somewhere between 1 and 3 astronomical units from the event horizon, closer to the Sun-Earth distance than to the Sun-Jupiter distance. Matter at ISCO orbits in hours or days, depending on the black hole's spin, racing around the circumference at significant fractions of light speed. And then something happens, a perturbation, a collision with other material, a magnetic instability, and it begins the final plunge. There is no sound. Sound cannot exist in the vacuum of space, cannot propagate through the plasma. There is no light escaping from the matter once it crosses the horizon. There is only absence, only the sudden disappearance of mass energy from our universe into a region from which no information can return. The efficiency of this process is staggering. Between 10 and 40% of the infalling matter's rest, mass energy is converted to radiation before crossing the event horizon, depending on the black hole's spin and the details of the accretion flow. E equals mc squared. Einstein's famous equation tells us that mass and energy are equivalent. Nuclear fusion in stars converts about 0.7% of mass to energy when hydrogen fuses into helium. Chemical reactions are far less efficient, about 1/1000th, but black hole accretion reaches efficiencies of 10 to 40%, making it the most efficient energy generation mechanism in the known universe, and the most terrifying. Every year, matter equivalent to 20 to 30 times the mass of our Sun crosses the event horizon of TON 618, vanishes forever from our universe, adds its mass to the black hole, and yet the black hole grows by only 0.00%, an increase so tiny that it is barely measurable, because the black hole is already so massive that adding 30 suns worth of matter is like adding a grain of sand to a mountain. It is nearly infinite in its capacity, and it is still eating, still consuming, still growing, and will continue doing so until the gas supply is exhausted or feedback effects shut down the accretion. Have you ever stood next to a stove and felt heat radiating onto your face? Felt the warmth increase as you move closer to the burner? That heat is perhaps 200 degrees Celsius, uncomfortable but survivable for brief periods. The inner accretion disk reaches 10 billion degrees. Your brain has no frame of reference for this temperature. Nothing on Earth, not volcanic lava, not lightning, not nuclear weapons comes close. Nothing in our solar system approaches this temperature, except perhaps briefly during supernova events. This is heat on a scale that exists only at the edge of black holes and in the first seconds after the Big Bang. People say nothing escapes from a black hole. Wrong. Energy escapes in the form of light, X-rays, gamma rays, radiation across the entire electromagnetic spectrum. What does not escape is matter, information, and hope. Once you cross the event horizon, your fate is sealed. The singularity is in your future as inevitably as tomorrow. You cannot avoid it, cannot escape it, cannot change course. It is not a place you move toward, but a moment you move toward an event in your future. That will happen no matter what you do. If you think this story is frightening, remember, we are describing something real, not science fiction, not a horror movie, not a thought experiment. This is happening right now 10 billion light years. From here, or more precisely, it happened 10 billion years ago, and we are watching the light from that ancient catastrophe just now reaching our telescopes, just now arriving at Earth after its long journey through space. We are looking into the past, witnessing cosmic violence from when the universe was young. We have found it, we have seen it, we have measured its properties and calculated its mass and determined its distance. But the real question is not, what is it? The answer to that is clear. It is a supermassive black hole, consuming matter at a prodigious rate. The real question is, why is it here? How did this thing grow to 66 billion solar masses in only 3 billion years? The laws of physics say impossible. The mathematics say impossible. The equations that govern black hole growth, the limits imposed by radiation pressure and gas dynamics, the constraints on how quickly matter can fall into a black hole, all of them say this object should not exist. But it does exist. It is real. We can see it. And in the next episode, we will explore the secret that some scientists would prefer. You did not know the uncomfortable truth about TON 618 that challenges everything we thought we understood about how the universe works. The problem is simple to state, but impossible to solve. 66 billion times the mass of our sun assembled in only 3 billion years. This is not merely difficult. This is not just challenging our models. This is fundamentally, mathematically, physically absurd. The numbers do not work. The timeline does not work. The entire existence of TON 618 is an insult to everything we thought we understood about how black holes grow. The universe is 8 billion years old, born in the Big Bang, expanding and cooling ever since. The light we see from TON 618 was emitted when the universe was only 3.2 billion years old, less than 1/4 of its current age, when galaxies were still forming, when the first generations of stars had only recently ignited, when the cosmos was younger and more chaotic than it is today. This black hole had at most 3 billion years to grow from whatever seed it started from to its current incomprehensible mass. The Eddington limit is the fundamental constraint on how fast black holes can grow. It arises because accreting matter heats up and produces radiation, and this radiation exerts pressure on the infalling material, pushing it away. If accretion happens too rapidly, if too much matter tries to fall in at once, the radiation becomes so intense that its outward pressure overcomes gravity and blows away the infalling material, shutting down accretion. This is not a suggestion. This is not a guideline. This is a hard physical limit imposed by the laws of radiation and gravity and thermodynamics. The Eddington limit means a black hole can only grow so fast, even under ideal conditions, feeding continuously at the maximum possible rate. Growth is exponential, but not instantaneous. The mathematics are straightforward. Start with a seed black hole of 100 solar masses, perhaps formed from the collapse of one of the first massive stars in the early universe. Accreting at the Eddington limit, this black hole would grow with an e-folding time of roughly 50 million years, meaning its mass multiplies by a factor of e, about 2.7 every 50 million years. After 50 million years, 100 solar masses becomes about 270. After 500 million years, about 1 million solar masses. After 1 billion years, roughly 1 billion solar masses. After 1.7 billion years, theoretically 100 billion solar masses. So mathematically, growing a 66 billion solar mass black hole in 3 billion years is possible if you have continuous Eddington limited accretion from formation until observation. But this is wildly optimistic, assumes perfect conditions that probably never exist in reality. Black holes do not feed continuously. They experience periods of active feeding when gas is abundant, interspersed with periods of fuel shortage when the surrounding region has been cleared of matter. Accretion rates vary. Sometimes they might briefly exceed Eddington during what are called super Eddington episodes. Other times they fall well below during droughts when little material is available. Real black hole growth is messy, chaotic, intermittent. In 2012, an emergency meeting was convened at NASA headquarters. Senior astrophysicists from major institutions gathered to discuss observations of extremely massive black holes at high redshifts, TON 618 among them. The conclusion, though, not stated publicly in such blunt terms, was deeply unsettling. Either our theory is wrong, or something we do not understand is happening in the early universe. Can the Eddington limit be violated? Some quasars appear to be consuming matter at rates 5 to 10 times what theory permits, accreting so rapidly that by all rights they should blow away their own fuel supply, and yet they continue feeding. The observations are clear. The theory says impossible. Both cannot be fully correct. Then there is the fuel problem. Growing to 66 billion solar masses requires consuming several hundred billion solar masses of gas, even accounting for the inefficiency where 10 to 40% of mass energy radiates away before crossing the horizon. That represents a significant fraction of an entire galaxy's baryonic matter, all the normal matter composed of protons and neutrons. Where does it all come from? How do you funnel hundreds of billions of suns worth of gas into a region small enough to feed a black hole? Gas has angular momentum that tends to keep it in circular orbits rather than allowing inward fall. Overcoming this requires special mechanisms, galaxy mergers, gravitational torques, processes that may not operate efficiently enough to supply the necessary fuel. One physicist, speaking privately at a conference, admitted what many in the field were thinking: we do not know how this happened. We have theories, we have models, but the honest truth is, we do not understand how TON 618 grew so massive so quickly, and that keeps me awake at night. It is like seeing a 3-year-old driving an 18-wheeler truck down the highway. The issue is not that the child should not be doing, that should not have the keys, should not be allowed behind the wheel. The issue is that the child cannot do that. Physically, developmentally, biologically, cannot reach the pedals, cannot see over the dashboard, cannot have the strength or coordination or neural development required. The observation violates everything we know about children and trucks. TON 618 violates everything we know about black holes and cosmic time. If black holes were companies, TON 618 would be audited immediately. You grew too fast. Your mass increased at a rate inconsistent with known revenue streams. Are you committing fraud? Are you violating the laws of physics? And Ton 618 would shrug and continue existing indifferent to our confusion. There are 4 hypotheses attempting to explain this impossibility. Each one is crazier than the last. Each one requires special conditions that may or may not have existed in the early universe. Each one pushes our theories to their limits. And the terrifying possibility is that all 4 might be correct, might all be operating simultaneously, because the universe does not choose one mechanism when it can use all of them. Hypothesis: 1 massive seeds. Perhaps Ton 618 did not start from a stellar mass black hole of tens or hundreds of solar masses left behind by a dying star. Perhaps it began much larger, formed through direct collapse of an enormous primordial gas cloud into a black hole without ever going through a stellar phase. In the very early universe, before the first stars, there were regions containing vast clouds of pure hydrogen and helium, pristine gas, untainted by heavy elements, because no stars had yet lived and died to create them. Under special circumstances, if these clouds were prevented from fragmenting into smaller pieces, prevented from cooling efficiently enough to form stars, they might have collapsed directly into black holes, weighing 10,000 to 100,000 solar masses or more. This would provide an enormous head start, a foundation upon which further growth through normal accretion could build something like Ton 618 within the available time. But direct collapse requires extremely rare conditions. You need intense ultraviolet radiation from nearby young galaxies to prevent cooling, to keep the gas hot enough that it cannot fragment. You need the gas cloud to be massive enough and dense enough, and to lack the metals that would normally facilitate cooling and fragmentation. Finding these conditions is like searching for a needle in a haystack if the haystack were the size of the observable universe. Possible, yes. Common, probably not. Sufficient to explain Ton 618. Maybe if you're very lucky. Hypothesis: 2. Super Eddington accretion. Perhaps black holes occasionally violate the Eddington limit, feeding faster than theory predicts they should be able to. This might happen if the accretion flow is geometrically thick, forming a sort of envelope around the black hole rather than a thin disk. In such configurations, photons produced deep within might be trapped and advected inward before escaping to exert pressure on outer layers, allowing matter to continue falling in even as radiation is produced at super Eddington rates. Some theoretical models suggest super Eddington accretion rates reaching 5 to 10 times the classical limit might be sustainable for limited periods. Multiply the growth rate by 5 or 10, and suddenly the timeline becomes more plausible. A black hole that would take 3 billion years to reach a certain mass at Eddington-limited accretion might reach it in 300 million to 600 million years at 10 times that rate. The math works. The question is whether nature actually does this, whether the theoretical models reflect reality. Hypothesis: 3 black hole mergers. When galaxies collide, their central black holes eventually merge too instantly, creating a larger black hole through an event that releases more energy in gravitational waves than all the stars in the observable universe emit in light over the same time period. In the early universe, galaxies were smaller and more densely packed. Expansion had not yet carried them as far apart as today. Collisions and mergers were common, perhaps happening dozens or hundreds of times in the history of a single massive galaxy. Each merger adds the masses almost instantaneously. If TON 618's progenitor underwent 10 major mergers, each doubling its mass, that is a factor of 1,000 increase, without any slow accretion at all. Combine this with accretion between mergers, and growth becomes much faster. The energy released during these mergers is staggering. Two black holes spiraling together, distorting space-time around them, creating ripples that propagate across the universe, carrying away energy equivalent to several solar masses, converted entirely to gravitational radiation in the final seconds before merger. When black holes of billions of solar masses merge, the energy release briefly outshines all the stars in the visible universe. Combined, though the energy is in gravitational waves rather than light invisible to conventional telescopes. Hypothesis 4. The golden environment. The early universe was far richer in gas than today. Star formation had only recently begun, so most baryonic matter was still in gaseous form, still hydrogen and helium, rather than locked up in stars or blown into space by stellar winds and supernovae. This gas-rich environment provided abundant fuel for black hole growth. Galaxy mergers not only brought black holes together to merge, but also funneled enormous amounts of gas toward galactic centers through gravitational torques, stripping angular momentum from gas clouds, causing rapid inward fall that fed the central black holes. Perhaps TON 618 found itself in an exceptionally favorable location, maybe at the center of a protocluster, where multiple gas-rich galaxies were merging, where streams of cold gas flowed along cosmic filaments directly toward the forming galaxy, where every condition aligned to maximize black hole growth. Remove it from that special environment, and it could never have grown so large so fast. The quasar era at redshifts between z equals 2 and 3 represents a period roughly 1 to 4 billion years after the Big Bang, when quasar activity peaked. At that epoch, bright quasars were perhaps 100 times more common than today. The universe was in its teenage years, violent, chaotic, growing at rates that seem frightening in retrospect. Star formation rates were higher, galaxy mergers were more frequent, gas fractions in galaxies were larger. Everything conspired to make this the ideal time for growing supermassive black holes. The reality is probably that all four mechanisms operated together. The universe does not choose one pathway when multiple pathways are available. It uses all of them simultaneously, some contributing more than others, but all playing roles. TON 618 likely started from a massive seed formed through direct collapse, experienced periods of super Eddington accretion during particularly intense feeding episodes, underwent multiple mergers with other black holes during galaxy collisions, all while sitting in an optimal environment at the center of a forming galaxy cluster where gas was abundant and mergers were frequent. It is like trying to explain how someone gained 50 kilograms in 1 year. One reason would be concerning maybe a medical condition, maybe a major lifestyle change. 4 reasons operating simultaneously. That is not just concerning, that is catastrophic. That is every possible mechanism for weight gain happening at once. TON 618 is cosmic catastrophe, every possible mechanism for black hole growth operating at maximum efficiency at the same time. But how do we know any of this? How do we measure something 10 billion light years away, something we can never visit, never touch, never examine up close? The method will surprise you and probably frighten you a little. Measuring the mass of TON 618 is like measuring the weight of a person by listening to them scream. You cannot put the black hole on a scale. You cannot observe individual stars orbiting around it the way we can for Sagittarius A star at our galactic center, where decades of patient observation have revealed stars with known orbital periods allowing precise mass measurements through direct application of Kepler's laws. TON 618 is too far away, too ancient, too deeply embedded in its bright quasar glow to see individual stellar orbits. Instead, we use reverberation, mapping an indirect technique that exploits the finite speed of light and the structure of gas clouds around the black hole. The quasar brightness varies over time due to instabilities in the accretion flow, flickering on timescales of days to years, as turbulence and magnetic field reconnection cause changes in the accretion rate. When the central accretion disk brightens nearby, gas clouds orbiting the black hole, collectively called the broadline region, respond by brightening too. These dense clouds, heated and ionized by the intense radiation from the disk, fluoresce and emit strong spectral lines, particularly hydrogen Balmer lines. But there is a time delay between the disk brightening and the broadline region response, because light takes time to travel from disk to clouds. By monitoring both the continuum emission from the disk and the emission line strength from the broadline region over months or years, astronomers measure this light travel time delay. If the delay is 100 days, the broadline region extends roughly 100 light days from the black hole, about 26 billion kilometers. The spectral line widths broadened by the Doppler effect as gas orbits at different velocities reveal how fast the gas is moving. Faster orbital velocity at a given radius means more mass pulling on the gas. With both the orbital radius from the time delay and the velocity from line widths, we can calculate the central mass using basic gravity equations, the same physics that determines the Sun's mass from Earth's orbital properties, just applied to systems billions of times larger and billions of light years distant. For TON 618, specifically direct reverberation mapping is extremely difficult because the light travel times might be months or years, requiring long-term monitoring campaigns that are expensive in telescope time. Instead, astronomers use empirical relationships between quasar luminosity and broadline region size, calibrated using reverberation mapping of hundreds of other quasars, combined with single epoch spectroscopy measuring line widths. These methods consistently point to approximately 66 billion solar masses. But measuring mass by listening to light echoes is inherently imprecise. The uncertainty is enormous, perhaps a factor of 2 or 3 in either direction. The true mass could be 20 billion solar masses. It could be 200 billion. Both possibilities are terrifying. The error bars are plus or minus 200%. If a doctor told you your weight is somewhere between 50 and 150 kilograms, you would find a new doctor. But in astronomy, when measuring objects 10 billion light years away, this counts as precise. Independent confirmation comes from the Eddington limit. There is a maximum luminosity for any given black hole mass, beyond which radiation pressure blows away infalling matter and shuts down accretion. This quasar shines at about 4 times 10 to the 40th watts. For this luminosity not to exceed Eddington, the black hole must have a mass of at least 30 to 40 billion solar masses. The 66 billion solar mass estimate places TON 618 at roughly half to two-thirds of its Eddington luminosity, meaning very rapid accretion, but not quite at the absolute theoretical maximum, a reasonable value consistent with other bright quasars. The James Webb Space Telescope, launched in December 2021, has begun observing the host galaxy of TON 618 in unprecedented detail in infrared wavelengths, where the galaxy's starlight is more prominent relative to the quasar glare. These observations reveal a massive galaxy containing several hundred billion stars, undergoing intense star formation at rates perhaps 1,000 times faster than the Milky Way's current rate of 1 to 3 solar masses per year. This vigorous star formation connects to the same gas-rich conditions feeding the central black hole. In the 2030s, the Laser Interferometer Space antenna LESA will be launched to detect gravitational waves from supermassive black hole mergers. When two black holes, like TON 618, spiral together, they produce gravitational waves detectable across the entire universe, ripples in space-time itself that carry information about the masses, spins, and orbital parameters encoded in the wave pattern. We will hear the sound of space-time groaning under the strain of these mergers. Listen to the universe's fabric vibrating like a drum. Measuring TON 618 is like standing in New York, hearing a sound from Tokyo, and calculating the weight of whatever made that sound based solely on how the sound waves propagated through the atmosphere. Absurd, yes. Impossible, no. We do it anyway. We have no choice. This is the only way to measure objects at cosmic distances. The crazy part: all these different methods give similar answers. Reverberation mapping says 66 billion. Eddington limit says at least 30 billion. Host galaxy properties suggest a black hole of this mass range. It is as if the universe wants us to know. The truth keeps giving us consistent answers through completely different measurement techniques, confirming that, yes, this monster is real, is as massive as we calculated, is genuinely breaking the rules we thought governed black hole growth. We know it exists. We know it is massive, beyond comprehension. But now we step inside. We approach from several light years out, still safely distant, but already the environment begins to change in ways that would be lethal to any unshielded observer. The quasar dominates our view, no longer just a point of light, but a blazing beacon that outshines everything else in this region of space. Brighter than all the galaxies we have passed, more luminous than anything except perhaps the primordial fireball of the Big Bang itself. The radiation at this distance is already deadly. High-energy X-rays and ultraviolet photons flood the space around TON 618, a bath of energetic radiation that would deliver a lethal dose within hours or days to any biological organism. Radiation shielding would be essential for survival. Thick layers of lead or water or some advanced material we have not yet invented. Electronics would begin to malfunction as radiation creates spurious signals and damages semiconductors. This is not a place for the living, not a place for machines, not a place for anything except the doomed matter falling toward its destruction. At 1 light-year distance, roughly 6 trillion miles from the event horizon, the quasar's apparent brightness increases dramatically, becoming comparable to the sun's intensity as seen from Earth, but with a far more extreme spectrum. Substantial emission in the ultraviolet and X-ray regions would instantly destroy unprotected biological tissue, breaking chemical bonds, ionizing molecules, unraveling the delicate structures that make life possible. Your DNA would be shredded by high-energy photons before you could register what was happening. Space around us fills with the quasar's radiation field. Photon density is high enough that photons interact with stray atoms, ultraviolet photons striking hydrogen and knocking electrons free through photoionization, X-rays ionizing even tightly bound electrons from heavier elements. The result is a vast bubble of hot, ionized plasma surrounding the quasar, heated by intense radiation to millions of degrees, extending for light years. In all directions, a region where matter cannot exist in any familiar form. Moving inward to light months distance, perhaps a few trillion miles, the quasar resolves into extended structure. What was a point source spreads into a disk, revealing the accretion disk as a distinct feature, a vast swirling maelstrom that we described earlier but can now see directly. The disk shows clear structure, outer regions glowing orange and red at tens of thousands of degrees, middle regions shining yellow and white at hundreds of thousands of degrees, innermost visible regions blazing blue-white, and violet approaching millions of degrees. Relativistic beaming becomes dramatically apparent, one of the strangest effects predicted by special relativity. The side of the disk rotating toward us appears much brighter than the receding side, not just because of the ordinary Doppler effect shifting light to higher energies, but because of relativistic beaming itself. When matter moves at significant fractions of light speed, the radiation it emits becomes concentrated in the forward direction, beamed like a searchlight in the direction of motion. Material moving toward us beams its light in our direction, appearing several times brighter than material moving away that beams its light elsewhere. The asymmetry is dramatic and unmistakable. At this distance, matter in the inner disk is moving at 30 to 50% of the speed of light, fast enough that relativistic effects dominate everything about how the system appears. Light from material approaching us is blue shifted, compressed to higher frequencies and higher energies. Light from receding material is red shifted, stretched to lower frequencies. The combined effect means we see a lopsided disk, one side brilliant, the other dim, even though intrinsically both sides emit similar amounts of light. Photon-photon interactions become important as we push closer, a quantum mechanical effect that occurs only at extremely high photon densities. When photons collide with sufficient energy, they can create matter, specifically electron-positron pairs, matter and antimatter from pure energy E equals mc squared running in reverse. These pairs are short-lived, annihilating when they meet and converting their mass back to energy, back to photons. But briefly, we have a sea of particles and antiparticles constantly being created and destroyed, a boiling quantum foam of matter and energy at temperatures and densities found nowhere else in the modern universe, except perhaps during neutron star collisions. Within light weeks distance, gravitational lensing becomes dramatically apparent. Light from the disk's far side, which should be hidden behind the black hole, bends around it through the extreme space-time curvature, reaching our eyes. We see a complete emission ring surrounding the black hole, silhouette light from both the near side traveling relatively straight, and the far side bent around the hole, arriving simultaneously. We see the disk above below, and as a ring around the black hole, all at once a surreal arrangement, possible only in extremely curved space-time. The event horizon itself extends to about 1,300 astronomical units from the center, roughly 1,300 times the Earth-Sun distance, or about 40 times Pluto's average distance from the Sun. The circumference measures roughly 8,000 astronomical units around. Traveling at light speed along this boundary would take nearly 6 weeks for a complete circuit. This is not a small object. This is a structure larger than our entire solar system, a boundary enclosing a volume of space within which all future directed paths point inward toward the singularity. The event horizon is not a physical surface, but a feature of space-time geometry, a boundary defined by Einstein's equations. Below this boundary, space-time warps so severely that all trajectories, all possible world lines, all paths through space-time that move forward in time point inward toward the singularity. Above the boundary, escape is still possible with sufficient velocity. Below, escape is impossible, not because you lack the energy, but because space-time geometry itself forbids it. You cannot go back the way you came any more than you can travel backward in time. The event horizon is like a one-way door. Entering is easy, exiting never. Not difficult, not improbable, not requiring advanced technology or enormous energy, simply never prohibited by the mathematical structure of reality itself. Crossing the event horizon from your own perspective, falling inward, nothing special happens. There is no physical barrier, no sudden sensation, no local indication that anything has changed. You simply pass from a region where escape was possible to one where it is not. The laws of physics do not suddenly change. Space-time does not tear. You do not feel anything different. If you had instruments sensitive enough and a theoretical framework sophisticated enough, you could detect that you had crossed by, noting that all light cones, all possible futures now point inward. But there is no wall, no membrane, no surface. Looking back toward the outside universe, after crossing, you can still see it. Light from outside falls inward freely, so you continue receiving images from the external universe. However, the images are increasingly distorted and blue-shifted, compressed by the extreme gravitational field and the Doppler effect of your inward motion. The entire outside universe becomes compressed into a shrinking circle. Behind you, all of creation, visible through an ever-narrowing window. If you tried sending signals back, they would never escape. Radio waves, laser beams, anything you emit falls inward, with you trapped by the same space-time geometry, trapping your body. Your messages will never reach anyone outside. You are cut off completely, irreversibly, forever. Welcome to the event horizon. The rules are simple. Don't. But if you're already here, enjoy the last few hours of your existence. There is no customer service to complain to. There is no emergency exit. There is only the singularity waiting ahead, inevitable as tomorrow. And now, there is no turning back. Ahead lies only one thing, the singularity, the place where physics ends and our understanding fails. Inside the event horizon, the singularity is no longer a place in space, but a moment in your future, as inevitable as tomorrow, as unavoidable as the passage of time itself. You cannot change course. You cannot slow down. You cannot stop. The singularity is not something you move toward through space, but something you move toward through time, an event that will happen to you no matter what you do, no matter how you struggle, no matter what engines you fire or what trajectory you attempt. Tidal forces barely noticeable at the horizon for a black hole this massive begin to grow as you fall deeper. Initially, the increase is gradual, almost imperceptible. You feel slightly stretched, pulled more strongly at your feet than at your head if you are falling feet first, simultaneously compressed horizontally, squeezed from the sides. These are tidal forces, differential gravitational effects arising from space-time curvature, from the fact that different parts of your body experience slightly different gravitational fields. The forces intensify exponentially as you approach the singularity. What began as mild discomfort becomes pain, then agony, then overwhelming stress, exceeding the breaking strength of biological tissue, then exceeding the breaking strength of any material. Your body tears apart first macroscopically as bones break and muscles rip, then microscopically as cells are disrupted, then molecularly as chemical bonds break. This is spaghettification, the inevitable consequence of falling toward a singularity. Your body stretched into long, thin strands, like spaghetti, pulled apart by the inexorable mathematics of curved space-time. For this ultramassive black hole, the journey from horizon to singularity takes many hours, perhaps days of subjective time, measured by your own clock, much longer than for smaller black holes, where the journey might take only seconds or minutes. The longer journey is a consequence of the black hole's size. Larger black holes have gentler curvature near their horizons, translating to weaker initial tidal forces and longer time before the forces become lethal. But eventually, inevitably, the forces become overwhelming. Your body stretches into long, thin strands, then tears apart, completely disintegrated into individual atoms, then subatomic particles. Finally, in the last moments, even fundamental particles might be affected as you approach the singularity, where space-time curvature becomes infinite. The time paradox of black holes is deeply strange. From your perspective, falling in the journey from horizon to singularity takes hours or days, your clock ticking, normally time passing, at what seems like a normal rate. But from the perspective of someone outside watching you fall, you never cross the horizon. They see you approach the boundary, slow down, freeze at the horizon, your image becoming increasingly red-shifted and dimmed but never actually crossing. You are frozen there forever from their perspective, caught at the boundary between inside and outside, trapped in a moment that from your perspective lasted microseconds, but from their perspective lasts eternally. Then you reach the singularity, the end point, where all infalling matter concentrates according to classical general relativity. At the singularity, space-time curvature becomes infinite. Density becomes infinite. Pressure becomes infinite. The equations of general relativity break down, produce nonsensical results, predict infinities, clear signs that the theory is incomplete, that we are pushing it beyond its domain of validity. This is where current physics fails. We do not know what actually happens at the singularity. General relativity predicts its existence, but cannot describe its properties, cannot tell us what occurs when curvature becomes infinite. A quantum gravity theory is needed, a framework that unites quantum mechanics with general relativity, and we do not yet have such a theory despite decades of effort. Several candidates exist, including string theory, which proposes that fundamental particles are actually tiny, vibrating strings, and loop quantum gravity, which suggests that spacetime itself is quantized, made of discrete units, rather than being continuous. But none has been definitively confirmed through experiment or observation. These theories suggest the classical singularity might be replaced by something else, perhaps a region of high but finite curvature where quantum effects dominate, or perhaps some kind of bounce where collapsing matter rebounds outward, or perhaps something stranger we have not yet imagined. The information paradox adds another layer of mystery. Quantum mechanics insists that information cannot be destroyed, that the quantum state of a system evolves deterministically, that if you know the initial state perfectly and track all interactions, you can, in principle, reconstruct what happens at any later time. But black holes seem to destroy information. Everything that falls in becomes trapped, and from outside, we lose all information about what fell in except total mass, charge, and angular momentum. Stephen Hawking complicated things in 1974 by showing that black holes are not entirely black. Quantum effects near the event horizon cause black holes to emit thermal radiation, now called Hawking radiation, with a characteristic temperature inversely proportional to mass. For TON 618, the temperature is unimaginably tiny, far below the cosmic microwave background temperature. So the black hole actually absorbs more radiation than it emits, and will continue doing so until the universe cools substantially more. But in principle, over timescales of 10 to the 100th power years, the black hole will slowly evaporate, shrinking as mass energy is radiated away. The problem is that Hawking radiation appears to be purely thermal, containing no information about what fell into the black hole. It is like burning an encyclopedia and claiming the smoke contains all the information that was in the book. The mathematics says the information is gone, destroyed, lost forever. But quantum mechanics says this is impossible. Both theories are extraordinarily well tested. Both cannot be fully correct. Something has to give. Dying inside a black hole is both infinite and instantaneous. From your perspective, it takes hours' time, stretching subjectively, as tidal forces pull you apart, pain increasing, body disintegrating, consciousness ending. From an outside perspective, You are frozen at the horizon forever, never quite crossing your image, redshifting and dimming, but never disappearing. Both perspectives are correct. Both describe the same event. Reality is stranger than fiction, weirder than the human mind evolved to comprehend. Hawking radiation means black holes evaporate. TON 618 will take 10 to the 100th power years to completely evaporate. The universe is currently 13.8 billion years old, which is 1.38 times 10 to the 10th years. The ratio is 10 to the 90th, meaning the black hole's lifetime is 10 billion trillion times longer than the current age of the universe. Basically, eternal undersells it. Forever is an understatement. This black hole will outlast everything, will persist long after all stars die, after all galaxies disperse, after protons themselves might decay. This is where the story ends, according to theory. We have reached the singularity, the point where physics breaks down and knowledge fails. But the real story is just beginning, because TON 618 has changed how we see the universe, has challenged our theories, has forced us to confront the limits of our understanding and ask questions we did not know we needed to ask. We have seen hell. We have understood it, measured it, described it mathematically. But the final question is not about the black hole. It is about us. Why do we dare to look at things we should not look at? Why do we point our instruments at cosmic horrors that could erase us without noticing? Why do we seek knowledge that offers no practical benefit, that will never improve our daily lives, that serves only to satisfy curiosity? The answer to that question defines what it means to be human. The black hole does not exist in isolation, floating alone in the cosmic void. It sits at the heart of a massive galaxy, a host system whose properties remain partially mysterious due to the overwhelming glare of the quasar itself, like trying to photograph a candle flame while standing next to a searchlight, or measuring the light from a single star while the sun blazes beside it. The host galaxy of TON 618 contains several 100 billion stars, a massive system comparable to or exceeding the Milky Way in stellar mass, though we are seeing it as it existed 10 billion years ago, when the universe was younger and galaxies were still in their formation phase. These stars are not distributed in the orderly spiral pattern of mature galaxies, but are probably arranged more chaotically, evidence of recent mergers and violent interactions that brought enormous amounts of gas into the galactic center to feed the black hole. The galaxy is undergoing star formation at rates perhaps 1,000 times faster than the Milky Way's current rate of 1 to 3 solar masses per year. This means every year mass equivalent to 1,000 suns is being converted from gas into new stars, a furious pace of stellar birth that cannot be sustained indefinitely, that will exhaust the available gas supply within tens of millions of years. This vigorous star formation connects directly to the same gas-rich conditions feeding the central black hole. Both processes require abundant fuel, and in the early universe, when TON 618 existed, in real-time gas was far more plentiful than today. But this intense activity carries the seeds of its own destruction. The quasar's radiation has a profound effect on its surroundings through what astronomers call AGN feedback, active galactic nucleus feedback processes. by which the black hole's energy output affects the host galaxy and its ability to continue forming stars and feeding the black hole. The radiation is so intense that it heats surrounding gas, raises temperatures to millions of degrees, gives gas particles enough thermal energy to escape the galaxy's gravitational potential well entirely. Ultraviolet and X-ray photons ionize gas throughout the galaxy, stripping electrons from atoms, preventing the gas from cooling and collapsing to form new stars. Hot ionized gas has high pressure and resists gravitational collapse. If heated strongly enough, gas can be blown out entirely in powerful winds driven by radiation pressure, removing fuel for both future star formation and continued black hole growth. This self-regulation may explain why the most massive black holes eventually stop growing, why TON 618 did not continue feeding until it consumed its entire galaxy. Some quasars, and TON 618 might be among them, though we cannot observe this directly, across such distances produce powerful jets, collimated beams of matter and energy shooting from the black hole's poles at velocities approaching the speed of light. These jets can extend for millions of light years, far beyond the visible galaxy, punching through the interstellar medium and creating enormous bubbles in the intergalactic space. The plasma in these jets reaches temperatures of 10 to the 12th Kelvin, 1 trillion degrees, hotter than anything in nature, except perhaps the first microseconds after the Big Bang. The jets plow through surrounding gas, heating it, pushing it aside, creating radio-emitting bubbles that can be 10 times larger than the visible galaxy structures so vast that they dwarf anything else in the local universe. The energy deposited by these jets prevents gas from cooling and falling back toward the galactic center, effectively starving the black hole and shutting down further growth. Every heavy element in your body, every atom of carbon and oxygen and nitrogen and iron, every element heavier than lithium, was forged inside stars that later died and scattered their enriched material back into space. Some of these elements might have been created in the vicinity of quasars, like TON 618 synthesized in the intense radiation fields and high-energy particle collisions near supermassive black holes, then blown out into intergalactic space by jets and winds to eventually be incorporated into later generations of stars and planets and people. You carry in your body atoms that might have witnessed events near black holes billions of years ago. Right now, in the actual present moment, that TON 618 is experiencing 10 billion light years away, the quasar has almost certainly shut off. We are seeing a 10 billion-year-old corpse that still shines brighter than 100 billion suns, but that is ancient light from ancient violence. Today, in real time, the black hole probably sits dormant at the center of a massive elliptical galaxy, a giant system containing trillions of old red stars formed billions of years ago during the galaxy's violent youth. The gas supplies have long since been exhausted or expelled. Star formation has declined to near zero. The galaxy has aged and quieted, settling into the quiescence typical of massive elliptical galaxies. In 4 billion years, our own galaxy will experience something similar when Andromeda collides with the Milky Way. The two central black holes, Sagittarius A star and Andromeda's central black hole, will eventually spiral together and merge, creating a new black hole, weighing perhaps 100 million solar masses or more. Gas shocked and compressed by the collision will funnel toward the center, potentially reigniting quasar activity, briefly turning our merged galaxy into a blazing beacon visible across cosmic distances before feedback effects shut everything down again and the system settles into dormancy. Quasars are like violent youth. They live fast, die young, leave chaotic legacies written in the structure of their host galaxies and the chemistry of intergalactic gas. But without them, we would not exist. Without the feedback that regulates galaxy growth, without the heavy elements scattered by quasar-driven winds, without the energy that heats intergalactic gas and affects how future galaxies form the universe would be a different place, and the conditions that allowed life to emerge on Earth might never have occurred. TON 618 is not just a record. It is not merely the most massive black hole. We have found not simply an extreme object to catalog and study. It is a lesson about the limits of nature, about how far physical processes can be pushed about the maximum structures that gravity can assemble in our universe. And it is a lesson about the limits of human knowledge, about our ability to measure and understand objects separated from us by distances and times that dwarf human experience. Humanity has measured something 10 billion light years away, something we have never touched, never seen directly, except as ancient photons, something that existed before our planet formed, before our sun ignited, before anything in our solar system came into being. This achievement deserves contemplation. We are primates, evolved from tree-dwelling ancestors, developing bigger brains, primarily to navigate social relationships and find food, surviving on an unremarkable planet around an ordinary star in the outer regions of a typical galaxy. And yet we have reached across cosmic gulfs to determine the mass of a black hole that could swallow our entire solar system. The black hole does not care that we exist. It does not know we observe it. It does not register our measurements, or our theories, or our attempts to understand. It simply exists, governed by physical laws, indifferent to the 7 billion humans on a small wet rock who happen to develop enough intelligence and curiosity to point telescopes in its direction. This indifference might seem depressing, might suggest our cosmic insignificance, but the indifference does not diminish the value of what we have accomplished. Reality is stranger than imagination, weirder than fiction, more extreme than human intuition suggests possible. Black holes were predicted mathematically before they were observed solutions to Einstein's equations that seemed so bizarre that many physicists, including Einstein himself, doubted they could actually exist in nature. The mathematics said yes, but intuition said no. Nature sided with the mathematics. The universe creates black holes, lots of them, some of them monsters, beyond anything we imagined. From primitive origins, perhaps 100,000 years ago, when anatomically modern humans first emerged in Africa, using stone tools and living in small bands, to today when we can measure black holes 10 billion light years away, this represents an almost incomprehensible intellectual journey. We have gone from not understanding fire to understanding space-time curvature, from not having written language to encoding the laws of physics in mathematical equations, from thinking Earth was the center of everything to knowing we orbit an ordinary star in an ordinary galaxy in a universe containing billions of galaxies, each containing billions of stars. Every answer we find generates new questions. We now know Ton 618 exists, know its approximate mass, know roughly how it formed. But we do not fully understand the details. We do not know whether the information that falls into it is truly destroyed or somehow preserved. We do not know what happens at the singularity where our equations break down. We do not know if there are processes we have completely missed, physics we have not yet discovered that might change everything we think we understand. The information paradox remains unsolved, a puzzle that has troubled physicists for 50 years, since Hawking first articulated it. Quantum mechanics says information cannot be destroyed. General relativity says information falling into black holes is lost forever. Both theories are extraordinarily well tested in their respective domains. Both cannot be fully correct about black holes. We probably need entirely new physics to resolve this, a theory that goes beyond both quantum mechanics and general relativity, that unifies them into a complete theory of quantum gravity. The universe does not need us. It was here before we existed. It will be here after we are gone. Every star will eventually exhaust its fuel. Every galaxy will eventually disperse. Even protons might decay, given enough time, 10 to the 35th years or more. But black holes will persist far longer than any of that. Ton 618 will take 10 to the 100th power years to evaporate completely through Hawking radiation, a time span so vast that the current age of the universe, 13.8 billion years, is utterly negligible by comparison. In 10 to the 100th power years, humanity will have been extinct for almost the entire span. Earth will have been vaporized. When the sun became a red giant, then frozen when the sun became a white dwarf, then perhaps dispersed entirely. The Milky Way will have long since merged with Andromeda, and eventually dispersed as its stars were gravitationally ejected or fell into the central black hole. Every star will have died. The universe will be cold and dark and empty, except for black holes slowly evaporating, and perhaps some exotic particles we have not yet discovered. But we do not need to outlast the universe to matter. We do not need to be eternal to be meaningful. The universe does not need us, but we need to understand the universe. That need, that drive to comprehend, to measure, to theorize, to push the boundaries of knowledge, that is what gives meaning to the brief flicker of consciousness that is a human life, the short moment between birth and death, when we are aware and thinking and capable of looking up at the night sky and wondering what it all means. I will die. You will die. Everyone reading this will die within perhaps 100 years, a cosmic eye blink utterly negligible on the timescales we have been discussing. But the information we have gathered about Ton 618, about black holes, about the structure and history and fate of the universe, that information will be passed on to the next generation, and the generation after that, accumulated and refined and expanded, added to the great edifice of human knowledge that is our species' primary legacy. In 10 to the 100th power years, Ton 618 will finally evaporate, the last of its mass converted to radiation, the black hole disappearing in a final burst of Hawking radiation. At that point, if any intelligent species exists to observe it, they might look at the data and ask, what was this thing? How did it form? What does it tell us about the early universe? And the cycle will begin again, curiosity driving understanding questions, leading to answers, leading to more questions. This is not a story about a black hole. This is a story about evolved primates who dared to look at the face of the universe and ask, why? Why does this exist? How did it form? What does it mean? Those questions have driven every scientific advance, every technological breakthrough, every expansion of human knowledge. From the first humans who wondered about thunder and lightning, to the modern astronomers who measure black holes billions of light years away. But the story is not finished. There are other black holes out there, bigger ones, stranger ones. We will find them. We will measure them. We will try to understand them, and each discovery will raise new questions, reveal new mysteries, push us toward deeper understanding. The tools we will use to study black holes in the coming decades represent quantum leaps beyond current capabilities instruments that will let us see farther, measure, more precisely detect phenomena completely invisible to today's telescopes. These technologies will answer current questions, but as always, in science will raise new questions, even more profound than the ones we started with. The extremely large telescope, currently under construction in Chile's Atacama Desert, will have a primary mirror 39 meters in diameter, larger than any existing optical telescope, composed of 798 hexagonal segments, precisely controlled to act as a single coherent surface. When it begins observations around 2025, it will collect 16 times more light than current large telescopes, achieve angular resolution good enough to see details on the surfaces of distant stars, measure the properties of galaxies at the edge of the observable universe. For quasars, like TON 618, the ELT will enable far more detailed spectroscopy, better measurements of black hole masses through reverberation, mapping potentially even resolved observations of the host galaxy structure. Despite the overwhelming quasar glare, if the ELT were a human eye, you could see a mosquito on the moon, or nightmares in the cosmos. Depends on your perspective. The laser interferometer, space antenna planned for launch in the 2030s, will detect gravitational waves from supermassive black hole mergers across the entire observable universe. LISA will consist of 3 spacecraft flying in a triangular formation separated by 5 million kilometers, using laser interferometry to detect space-time distortions caused by passing gravitational waves. When 2 black holes of billions of solar masses spiral together and merge, they produce gravitational waves that LISA will detect as a characteristic chirp, rising in frequency and amplitude as the black holes orbit faster and closer, then going silent as they merge into a single object. LISA will hear the heartbeat of the universe, listen to space-time itself vibrating under the strain of these cosmic collisions, detect mergers involving black holes, like TON 618 from across cosmic time. The gravitational wave signal encodes information about masses, spins, orbital parameters, potentially even exotic physics, beyond general relativity, if deviations from Einstein's predictions exist. We will hear the universe groaning. The James Webb Space Telescope, already operational since 2022, is finding quasars at extremely early times, objects at redshifts greater than 10 corresponding to when the universe was less than 500 million years old. Some of these early quasars appear to harbor black holes of billions of solar masses existing even earlier than TON 618 objects that are even more impossible, according to standard formation theories. Webb might find black holes that make TON 618 look ordinary objects that should not exist, but do, forcing us to completely revise our understanding of black hole formation in the early universe. The Event Horizon Telescope, which produced the first images of black hole shadows for M87 and Sagittarius A*, might eventually image TON 618 if the technology advances sufficiently. Currently, the array lacks the sensitivity to image such a distant quasar, but future expansions adding more telescopes and improving correlation techniques might make it possible. Imagine seeing the actual shadow of TON 618's event horizon, the dark circle, marking the boundary of no return silhouetted against the bright accretion disk. Imagine confirming that Einstein's equations describing space-time curvature are accurate even for something this extreme. Athena, the Advanced Telescope for High-Energy Astrophysics, planned for the 2030s, will study X-rays from black hole accretion disks with unprecedented spectral resolution by measuring the shape of iron emission lines distorted by relativistic effects and gravitational redshift. Athena will determine black hole spins, measure how fast the event horizon is rotating, test whether Einstein's description of rotating black holes is correct. Spin is crucial for understanding black hole formation and evolution, but current measurements are crude. Athena will measure spins for dozens or hundreds of supermassive black holes, map out the spin distribution, test formation theories. Artificial intelligence and machine learning will play increasing roles in astronomy, analyzing enormous data sets from surveys, finding patterns humans might miss, optimizing observation strategies. Neural networks can learn to recognize quasars in photometric data, classify objects faster than human astronomers, can search through millions of images to find rare objects worthy of detailed follow-up. Machine learning can analyze spectra, identify unusual features, discover outliers that might represent new physics. These tools amplify human capabilities. Let us process data at scales impossible for unaided humans. Multi-messenger astronomy, combining electromagnetic observations with gravitational waves, neutrinos, and potentially other signals we have not yet discovered, will provide complete pictures of cosmic events. If a black hole merger produces both gravitational waves detected by LISA and electromagnetic emission from surrounding gas detected by conventional telescopes, we learn things impossible to determine from either signal alone. The gravitational waves tell us about space-time geometry and black hole properties. The electromagnetic emission tells us about gas distribution and composition. Together, they provide complete understanding. Future technology is like opening new eyes. Each time we open them, we see something more frightening than before, something that challenges our understanding, something that forces us to question assumptions we thought were secure. The ELT will find more extreme objects. LISA will detect black hole mergers we currently do not know exist. Webb is already finding quasars that should not be there. Athena will measure properties we thought were unmeasurable. These technologies will answer questions, but they will also create new questions, stranger questions, more disturbing questions about the nature of reality and the limits of physical law. And we will pursue those questions because that is what we do. What defines us as a species? What gives meaning to our brief existence in a cosmos that does not need us, but which we insist on understanding anyway? TON 6-18 is exceptional, extraordinary, one of the most massive black holes ever discovered. But it is not entirely alone in its cosmic monstrosity. Astronomers have identified a handful of other ultramassive black holes approaching or possibly exceeding its mass, though uncertainties in measurement make definitive rankings difficult and contentious. Phoenix A, residing at the center of the Phoenix Cluster galaxy, at the heart of a massive galaxy cluster, may contain between 40 and 100 billion solar masses according to various estimates. The large uncertainty, the factor of 2 or more error bars, reflects the difficulty of measuring black hole masses in such systems. Phoenix A sits in an exceptionally favorable location, the center of a galaxy cluster, where hot intracluster gas provides an effectively unlimited fuel supply. The black hole can feed continuously from this reservoir, growing without the fuel constraints that limit isolated galaxies. S5 0014 Polos 81, a very distant quasar at redshift 3.36, even farther than TON 618, corresponding to when the universe was even younger, has been estimated at 40 billion solar masses. Its existence at such early times makes the formation problem even more acute. If confirmed, it strengthens arguments for massive seed black holes or super Eddington accretion in the early universe, suggesting that whatever allowed TON 618 to grow so massive so quickly was not a unique occurrence, but perhaps a common feature of the ancient cosmos. SDSS J07621-1 presents an even more extreme puzzle. Some estimates place it at 196 billion solar masses, which would make it far more massive than TON 618, nearly 3 times larger, approaching theoretical limits on black hole growth. However, this extreme estimate has been questioned by other astronomers. The uncertainties are enormous, and some suspect the actual mass may be significantly lower, perhaps only 40 or 50 billion solar masses, still ultramassive, but not quite as extreme. The controversy illustrates the difficulties of measuring objects at such distances. The problem is recurring. Every time we find the biggest, someone finds one bigger. TON 618 held the record. Then Phoenix A challenged it. Then SDSS J074621 might exceed both. Records are made to be broken, and in astronomy, where we are constantly improving instruments and surveying larger volumes of space, every record is provisional, temporary, awaiting the next discovery. How many more are out there? Theoretical calculations and survey extrapolations suggest there might be tens of thousands of quasars at TON 618's mass level, or higher, scattered throughout the observable universe. But we have found only a few dozen so far. Most are too distant, too faint, too obscured by dust, or too short-lived in their bright quasar phase for us to have detected them yet. Some might have already died. Their quasar phase ended, reduced to dormant black holes at galactic centers that no longer shine brightly enough to detect across cosmic distances. All the known ultramassive black holes sit at high redshift at distances corresponding to the early universe, the quasar era, between 1 and 4 billion years after the Big Bang, when conditions were optimal for rapid black hole growth. This is not a coincidence. It tells us something fundamental about cosmic history, about when and where these monsters can form. Is there a maximum black hole mass theory suggests yes, somewhere around 100 to 200 billion solar masses, beyond which feedback effects become so strong that further growth becomes impossible. Radiation pressure blows away in falling gas. Heated material escapes the galaxy entirely. Jets evacuate the central regions. The black hole effectively kills its own food supply, starving itself, ensuring it can never grow beyond this limit no matter how much time passes. Finding ultramassive black holes is like searching for needles in haystacks, if the haystack were the size of the observable universe. 93 billion light years across, containing 2 trillion galaxies, most of them too faint or too distant for current instruments to study in detail. TON 618 is the biggest we know for now. Give it 5 years. Someone will find something larger, something more extreme, something that pushes our theories even further. Records exist to be broken. That is the nature of science, of exploration, of pushing boundaries. Every answer reveals how much we still do not know. But TON 618 remains special, not because it is the largest, though it might be, not because it is the brightest or the most distant or the most extreme by any particular metric. It is special because it was one of the first that made us realize the universe has no limits, that nature creates things beyond our imagination, that physical law permits monsters we never anticipated. It opened our eyes to cosmic possibility. The journey ends here, 10 billion light years from where we started, having traveled from Earth through intergalactic space, backward through cosmic time, to witness a monster from the early universe, from our home planet to the singularity at the heart of one of the most massive black holes ever discovered. We have traced the full arc of this cosmic story. TON 618, 66 billion times the mass of our sun, 10 billion light years away, meaning we see it as it existed 10 billion years ago, shining with a luminosity of 140 trillion suns, making it one of the brightest objects ever observed, despite the immense distance its light has traveled to reach our telescopes. The timeline of discovery reveals how science works, how understanding accumulates gradually through patient observation and theoretical development. In 1957, astronomers at Tonantzintla Observatory recorded it as entry 618 in a catalog of blue stars. They had no idea what they had found. In the 1970s, improved instruments and better understanding of quasars revealed it was not a star at all, but something far stranger. In 2004, detailed mass measurements shocked the astronomical community. 66 billion solar masses should not exist, could not exist according to known physics, and yet there it was. In 2024, it remains among the top 5 most massive black holes known. By 2050, we might find larger ones, stranger ones, objects that make TON 618 look ordinary. If we could place TON 618 at Alpha Centauri's distance, 4.37 light years away, Earth's oceans would boil within 3 hours. The atmosphere would strip away. The surface would become molten rock. If we placed it at the Milky Way center, every planet harboring life within 50,000 light years would be sterilized by radiation, all life ending before it knew what killed it. The final message is simple. We cannot touch TON 618, cannot travel there, cannot affect it in any way, cannot change its trajectory or influence its evolution. But knowing it exists has changed us, has altered how we think about the universe, has pushed our theories, and forced us to confront the limits of our understanding. In 10 to the 100th, power years, every trace of humanity will have vanished. Our planet gone, our sun gone, our galaxy dispersed. No evidence we ever existed, except perhaps somewhere information encoded in radiation we sent into space that might outlast physical structures. But TON 618 will still be there, slowly evaporating through Hawking radiation, requiring no witnesses, caring nothing for the brief flicker of consciousness that once observed it from 10 billion light years away. Your life 80 years, if you're lucky. TON 618's lifespan, 10 to the 100th power years. But in those 80 years, you can understand it can know what it is, can comprehend its properties through mathematics and physics. That is power. That is meaning. That is what makes the brief human existence significant, despite our cosmic insignificance. People ask, why study black holes 10 billion light years away? What practical benefit does this provide? The answer, because it is there, and because we can. That's simple. Curiosity needs no justification. Understanding is its own reward. This story has no happy ending. No hero defeats the villain. No problem gets solved and wrapped up neatly. There is only evolved primates looking into the abyss looking back, and us refusing to blink, refusing to look away, insisting on understanding even when understanding offers no comfort. That is the entire story. TON 618 will outlast us, will outlast our descendants, will outlast Earth, the Sun, the Milky Way, all stars, all galaxies. But right now, at this moment, a species of animals on a small blue planet orbiting an ordinary yellow star, 10 billion light years away from that black hole, separated by distances and times that dwarf human experience, knows it exists. And knowing that changes everything. This is the story of TON 618. And this is the story of us.